We're going to take a look at an example of a two-sample t-interval here. So the problem states two researchers investigated the reliability of test assessment. One group consisted of 30 students who took proctored tests, and a second group consisted of 32 students who took tests online without a proctor. The two samples were taken independently and not paired or matched. Estimate the difference between the two means of the two groups with 95% confidence. And they provided us with the summary statistics for both of these groups. So as we can see, the proctored group has a mean of 70.29, and the non-proctored group has a mean of 74.26. So what we want to know now is how big of a difference would we expect to see if we were to get an entire population of students versus just our sample of 30 and 32. So let's start our four-step process. The first thing that's important to us is let's define our parameters. So here we are looking at the means of two groups, so that would be mu. And I'll just say the first one, since we have group 1 already labeled here, would be the mean test score of proctored students. And then for our other mean that we're trying to compare this to, we are looking at the mean score of our non-proctored students. And of course, what is it that we are actually trying to estimate here? We're trying to figure out how big of a difference, how much higher is one group than the other, or how much lower is one group compared to the other. So there's two ways we can write this. We can write this as either mu1 minus mu2 to find that difference, or we can do mu2 minus mu1. And again, the way we interpret this, we just have to make sure we understand the idea of what number is actually bigger in the end. So in this case, I'm going to put mu1 minus mu2 just to be consistent with what we've seen in terms of the order of things, the first minus the second. But when we're looking out for this, watch out, because the second value is actually the higher one than the first. So if we subtract these two things, it's likely that we're going to end up with some kind of negative number because we're taking a smaller number minus a bigger number. But what does this actually represent? This is going to represent the difference in mean scores between the two groups. So next, what is it that we're actually going to use here is going to be a two-sample t-interval. And again, we are using the t-distribution because we're trying to estimate means and we do not have our population standard deviations. So now we can move on to our step 3, which is our calculations. And as we've seen, even though there are formulas to help us out with this, we're going to typically just use ArtofStat or any other statistical calculator to do these calculators for us because they are a lot more tedious at this point. So to complete this, we're going to open up artofstat.com and we can go to our web apps. And what is it that we're trying to do is we're trying to compare two means. So what we're going to scroll down to is the confidence intervals and tests where we're comparing two groups. And here it is. We're trying to find an option to compare two means. And this is what comes up. Let's switch this to the type of data that we have. So do we either have the summary statistics or the raw data? And we know we have the summary statistics because these right here are what we call summary statistics. We don't have the actual scores of every single student. And so what is it that we're measuring? Let's just give it an appropriate response variable name. We're measuring test scores. And we have two groups. Our group 1, if you recall, what did we call that one? Was our proctored group. And our group 2 was our non-proctored. Again, how you label it, as long as it makes sense, is going to be fine. And then we can start putting in the information that was provided here. So for group 1, we see that we have 30 as our sample size, 70.29, and 22.09. And then for group 2, we have 32 as our sample size, 74.26 is the mean, and 18.15 is the standard deviation. And of course, we can see here what is the type of inference. Well, right now we're doing confidence intervals, and we're going to leave it at 95%. So if we look at our results here, we can find that our interval is given to us in this little section right here. It also gives us some of the other information that we need. For example, the descriptive statistics that we were entering in is provided. It also provides the interval as a point estimate. So this is the difference between these two numbers, the sample means, and our margin of error that we calculate using the formula. But what do we need the most is, again, after doing the point estimate plus or minus that margin of error, it's going to give us this lower bound and this upper bound. And as a visual, it also gives it to us as a picture. But let's just copy this interval right here. All right, so those are our calculations. We're just trying to figure out what is the lower and upper bound for our difference between two means. So now we can interpret what's being said. So our interpretation is going to follow the same interpretation that we've been doing for confidence intervals in the past. We can just say something like, we are 95% confident that the interval between negative 14.29 and 6.35 points, that's the units here since we're talking about test scores, actually contains. And be careful here, what is that we're trying to contain is a difference in mean scores between proctored students and non-proctored students. And here we have our 4 steps.